Okay. Dear students, you are welcome to this AICTE PRERANA scheme. So today, Dr. Kannan K, Associate Professor from Department of Mathematics, has to handle today class. So the AICT has given a lot of privilege and funding to you people for enabling you to make them you to get into higher education. For that, in this Prerana scheme, our Hindustan College of Engineering and Technology is funded by AICT Prerana, especially for your people, so that you are requested to utilize this particular opportunity and make use of this all the classes which we are going to conduct it through this Prerana scheme. All the classes, it is mainly handled by the eminent professors and who are all having a well experienced in their particular domain, so that that particular professor only going to handle the session. So the first session will schedule for the mathematics, and we have another one scheduled for the same mathematics subjects, and uh, and also we have a couple of weeks we have scheduled other core subjects in our mechanical, automobile, mechatronics, and as well as the biomedical, so that everyone will make use of this opportunity and make use this particular session for your higher education. And it is my kind request, this is not only for the gate examination. This particular things may support you for even in a competitive examinations. Even after completing your BE, you would like to go for some kind of uh, mm, uh, some IAS examination or IPS examinations. That's also, this particular classes will help you for taking into that particular level. And also the gate examinations not only for your higher education. So your mechanical and mechatronics, automobile, and biomedical students, you have a lot of opportunities in all central government sectors. If you want to get into the central government sectors, you have a special allotment for your community people. So if you have a good score or moderate score on average score in the gate examination, that will help you to get into all kind of central government sectors like DRDO, DST, ISRO, and all kind of ICMR. For taking biomedical students, you have ICMR, all kind of. I just listed only few, but we have hundreds of central government sectors. They are recruiting the people, especially they are recruiting the fresh engineering graduates, those who are having a gate score. So you don't think that this particular gate examination is only for getting into your PG studies. Okay, so just wipe out the particular one, your gate score, which will help you to get into central government job opportunities also. So with these short notes, I just over to today session, Dr. K. Kannan, sir, for carry out the session. Sir,
Thank you,
over
sir.
to you, sir.
Thank you,
Thank
sir.
you, sir.
Thank you. Good morning to all. Are you hear me? Anyone? Are you hear me?
Yes,
Okay.
sir.
Thank you. First of all, I would like to thank to our management and AICT CEO and Dr. Sabri for their conducting our gate coaching classes. And thank you. Today, I am going to discuss with the subject engineering mathematics. Actually, some of them audio will be on. Please mute your audio. Please mute your audio. Visible by my screen? Sabri sir, sir,
Yes, sir.
sir, please mute your modem.
Visible there.
Actually, I think.
Oh, okay, okay. Thank
Thank you. Okay. Um Good morning. Today I am going to discuss with some of the topics for about the engineering mathematics. Now, first I will be discuss with the linear algebra. Here, the first one is the rank of matrix. First of all, we have to consider let A be the given matrix. Suppose if you given the any matrices in m rows and n columns, first we consider A be the given matrix. Next of all, we have to try to convert lower triangular or upper triangular matrix. Lower triangular, upper triangle means already we know this. This matrix we have to arrange it to in terms of A11, A12, A13, and so on. In this case, we know this the diagonal elements. What are the diagonal elements here? A11, A22, A33. Below the diagonal elements, we converting to all the elements are 0. Otherwise, above the diagonal elements converting to 0. So it is called what? Lower triangle or upper triangle. Once we are asking the rank of matrix, first of all, we have to convert it to lower triangle or upper triangular matrix. After conversion of the lower triangle and upper triangular, we find out number of non-zero rows. Suppose the number of non-zero row is 2, so the rank of A is equal to 2. Number of non-zero row is 3, so the rank of A is equal to 3. For example, we will be consider find the rank of the matrix for the given matrix 1 2 minus 1 minus 5 1 3 minus 2 minus 7 2 minus 1 3 0. Okay, already we know this. A be the given matrix. Let us consider the given matrices is equal to A. Next, in a conversion of the lower triangular or upper triangular matrix, in the, below the diagonal elements, we converting to 0. This is a procedure for first step. Now, if always the first column we converting to 0. Next we have to converting to second column. Next we converting to third column. We have to use this same procedure. Now, by using the first row, first column element, we converting all other first column elements converting to 0. So, we compare these first steps here. Uh, Row 1 element is here 1. Here also 1. Now, always first we take the changing rows, next we take using rows. Now, R2 minus R1 because here 1, here also 1. So, we using the row is R1, change of the row is R2. So, interchange the elements 1 1. These sign are positive, all are same. So, in this case, we have to take the negative sign. Now, R2 changes with R2 minus R1. Similarly, we comparing this R1 and R3. So R1 is here, what is the elements here? 1. R3 is 2. Now interchange the elements 2 and 1. So here interchange the elements 1 and 2. So we using the row is R1. Change of the row is R3. The both the elements involving the same sign, no? So just we have to take subtractions. So R3 minus 2 into R1. So simply we are using these relations. So R2 minus R1. 1 minus 1, 0. 3 minus 2, 1. Minus 2, minus of minus 1, minus 1. Minus 7, minus of minus 5, minus 2. Next 2 minus 1, 0. 2 minus 2 into R1. Next minus 1, minus 4, minus 5. 3 minus of minus 1 into 2. So minus 5. Next 0, minus of minus 5 is equal to 10. Now we use the similar procedure. Second column elements we converting to 0. So uh, below the diagonal, next we convert this minus 5 is converting to 0. So just we have to compare this second row and third row values. Here 1, here minus 5, no? So we interchange the elements. So R3 plus 5 into R2. We use these relations. So automatically The third row converted to 0. All the elements will become a 0. Now, we have to identify number of non-zero rows. If all the elements are 0, we consider it is a 0 rows. Otherwise, it is considered non-zero rows. Now here, first and second row, any one of the elements is not equal to 0. So it is called non-zero rows. So number of non-zero rows is what? 2. So the rank of the matrix is considered 2. So the required answers of the given matrices rank is equal to what? 2. Next, by using this concept, again, the linear dependent and linear independent vectors. Linear dependent and linear independent vectors means they have uh, they have three methods there. One of the easiest method is the given n vectors. Suppose we given the three vectors, we will be take it will be formed to the given vector as in a row vectors. We have to form the matrix. After conversion of the matrix, we have to find out determinant. Otherwise we find out the rank. Okay, so the suppose if will be given the three vector, the matrices is considered 3 by 3 matrix. That means 3 rows and 3 columns. So if then NB is considered 3. Suppose we find out the rank of the matrix is 3. So it is called linear independent. Otherwise, linear dependent. Otherwise means suppose the rank is less than 3. Less than 3. In a order less than 3, we have to consider linear dependent. So for example, so that the vector is given x1 is equal to 1, 1, 2, x2 is given 1, 2, 5, and x3 is given 5, 3, 4, or linear independent or linear independent. Just we have to verify. Now, I have to consider first the given matrices A, B, it will be formed to by the given by using the given vectors. So what is the first vector? 1, 1, 2, 1, 1, 2. Next 1, 2, 5, 1, 2, 5. Next third row we have to take the third vector 5, 3, 4. Now we got it A. Now how to find out the rank? Already we discussed. First of all, we convert lower triangular or upper triangular. After conversion, the rank of matrix is equal to number of non-zero rows. It's correct. Now, here, 1, 1, 2, 0, 1, 3, 0, minus 2, minus 4. The first of all, we using these relations, automatically will be get this value. Now, again 1, 1, 2, 0, 1, 3, 0, 0, 0. We using this R3 plus 2 R2 relations, we get this matrix. Now, number of non-zero is 2. So, the rank of A is equal to 2. So, now what is the order of the matrix? The order of the matrix is 3. But the rank of given matrix is 2. So, it is a less than 3, you know. So, once we getting the less than 3, it is called a linear dependent. Suppose if the in this same question, suppose the rank of the matrix is 3, that is also equal to n. N be this given dimension 3 by 3 matrix. So it is called linear independent. Okay. Now, so that the vector x1, x2, x3 are linear independent. Now we have to see that one more examples for linear independent. Now first of all we consider A be the given matrix 2 minus 2 1, 1 4 minus 1 and 4 6 minus 3. After we have to try to convert it to lower triangle or upper triangle. As now we using these relations we have to convert it to lower triangle or upper triangle. Now we have to consider number of non-zero rows is now 1, 2, 3. So here in this matrix of the rank is 3. The dimension of given matrices is 3. So both are same. In this case, the given a vector is linear independent. So in our the linear algebra, they have only for the two possible questions. One of the question is what is the rank of the matrix? Any matrix is given, we have to identify the rank of the matrix. Next, so that linear independent or linear dependent of the given vectors. So once we ask in the linear independent or dependent of the given matrix, given vectors, just we have to convert, we find out the rank of the matrix. After conversions, after finding the rank, we have to identify it is a linear dependent or linear independent. Next, very important, it is a discuss about the consistency of the system of linear equations. If the system of linear equations means, linear means what is a linear equations? This given the variable, that means the algebraic equations involving to the power is 1, it is called what? Linear. So for example, x, one of the straight line is called what? Linear equations. For examples, y is equal to ax plus b, it is the general equations of straight line. This straight line is linear. Suppose quadratic means, suppose if we given y square equal to 4ax, it is called what? Parabolic equations. So if once involving the power of x is 2, it is called what? Quadratic. If we will be involving the maximum power is 3, it is a cubic equation. Generally, it is called what? Algebraic equations. Now we have to discuss about consistence of the system of linear equations. If once we given the simultaneous linear equations or linear equations, x1 plus a11 x1 plus a12 x2 plus a13 x3 equal to d1, a21 x1 plus a22 x2 plus a23 x3 equal to d2, a31 x1 plus a32 x2 plus a33 x3 is equal to d3, and so on. It is called what? The linear system of equations. It is also will be represent in the matrices form, ax equal to b. Suppose if the given equations we have to write down in this matrices form, how to written here? Ax equal to b. Here ax equal to b means first we take only the coefficients of x1, x2, x3. x1, x2, x3 coefficients we have to take one of the matrices. This matrices is for the value of a. Next, what are the variable x1, x2, x3? That is consider capital X. In this right side of the constant is d1, d2, d3 we consider b. So in this equations we have to return ax is equal to b form. Once we have to discuss about the consistency, first of all, to find out rank of A and rank of AB. After conversion of rank of A and rank of B, rank of A and rank of B, once the rank of A and rank of B, AB is not equal to not equal, rank of A not equal to rank of A comma B, it is inconsistent and no solutions. Suppose if the given system of linear equation is inconsistent, they have getting what? No solutions. It is not solvable for the given equations. Suppose if the rank of A equal to rank of A comma B, it is considered consistent. It is a consistence. Here also they have two possibilities. If the rank of A equal to rank of A comma B equal to n. Here n is defined by number of unknowns. Number of unknowns. Next, if rank of A equal to rank of A comma B equal to n, it is inconsistent and unique solutions. They have getting only for unique solution. Suppose if the rank of A equal to rank of A comma B and less than n, it is called consistent and infinite solution and infinite solutions. So for example, suppose investigate for what value of lambda mu the equations x plus y plus z is equal to 6, x plus 2y plus 3z is equal to 10, and x plus 2y plus lambda z is equal to mu have the given three conditions: no solution, a unique solution, and infinite number of solutions. First of all, by using the given system of equations, let us consider It is will be formed to matrices form. A already we know this. What is the meaning for A? The coefficients of x, y, z. What is x, y, z? X is 1, 1, 1. We have to write down in column wise. Y coefficients we take the second column. 1, 2, 2. And z coefficients we take third column. 1, 3 and lambda. Next, the right side value is we consider b. So 6, 10, mu. Now we find out the rank of A and rank of A comma B. Rank, how to find out the rank? Below the diagonal elements, we converting to 0. That means we convert it to upper triangular matrix. So now we using these relations R1 minus R2, R3 minus R1, we are to getting 1 1 1 6 0 1 2 4 0 and then 1 lambda minus 1 mu minus 6. After this again one more steps, second column elements we converting to 0, R3 minus R2, 1 1 1 6 0 1 2 4 0 0 lambda minus 3 mu minus 10. Now what is the given conditions? In the first condition, no solution. When will be exist no solution? If the rank of A not equal to rank of A comma B, then it is also will be getting no solutions. So in this case, rank of A means only will be consider the first three columns. Rank of AB means we consider all the columns. Now, suppose if we are getting the no solutions, it is a given condition. We will be consider it is a no solution. The rank of A not equal to rank of A comma B. Now, we will be consider lambda minus 3 equal to 0. So automatically the last row is converted to 0. No, suppose if we'll be taking the lambda minus 3 equal to 0, the third row, first three columns should be 0. So how many non-zero rows here? Only two rows. So the rank of A is equal to 2. Now mu minus 10 is considered not equal to 0. Lambda minus 3 equal to 0. Mu minus 10 is not equal to 0. If you now rank of A comma B, now we consider all the columns. Suppose we considering all the column, mu minus 10 is not equal to 0, lambda minus mu is equal to 0, number of non-zero value is non-zero row is what? 3. So in this case, rank of A comma B is 3, but rank of A is equal to 2. So it is not equal to no. So the no solutions means what are the possible solution? Lambda equal to 3 and mu is not equal to 10. Next, we consider unique solution. Unique solutions means what is our conditions? Rank of A equal to rank of A comma B. It is called a consistence, and also it should be equal to n. N means the number of unknowns. Unknowns means if now the given equation of system of equations x, y, z, you know, so this is called number of unknown variable. X, y, z is 3, you know. So we will be consider n is equal to 3. Appo unique solutions means rank of A comma B equal to n. So the rank is should be 3. So suppose we will be want this rank of A, number of non-zero row is 3, then only we'll be getting rank of A is equal to 3. So we consider lambda minus mu is not equal to 0. Now we take mu is equal to any value. Suppose mu is equal to 10, 10 minus 10, 0. But here lambda minus 3 is not equal to 0. So it is also will be considered non-zero rows. So what are the possibilities? Mu is any value, lambda is not equal to 3. Next, we take infinite solution. Infinite solutions means what? Rank of A equal to rank of A comma B and less than n. N be this number of unknowns. In this given problem, number of unknowns is 3. So less than 3. That means suppose the rank of A and rank of AB equal to satisfied 2 or 1. It is called what? Infinite solution. So what is the possibilities here? Now we take the third row will be converted to all the elements are 0. So what is the possibilities? Lambda minus 3 and mu minus 3 is equal to 0. So rank of A and rank of AB should be same and less than n. So lambda equal to 3 and mu is equal to 10. It is for the discussion about the consistency. Consistent and inconsistent means what? One second, I will be repeat. Once we given system of equations, we have to form it to matrices form. Matrices form in Ax is equal to B. First of all, we find out the rank of A and the rank of AB. After finding the rank of A and the rank of AB, we have to compare this both. If rank of A is not equal to rank of AB, rank of A is not equal to rank of AB, it is inconsistent and no solutions. Rank of A equal to rank of A comma B, it is inconsistent. If rank of A, rank of AB, once it is inconsistent, they have two possibilities. Equal to number of unknowns, it is unique solutions. If less than unknowns, it is infinite number of solutions. That's all. Next, we are going to discuss about the eigenvalues and eigenvectors. Now, the eigenvalues, eigenvectors already will be studied in our first semesters. It's correct. Now, eigenvalues and eigenvectors means first, it is the procedure for finding eigenvalues and eigenvectors. First of all, we consider A be the given system of given square matrix. Okay. Next, we find out the characteristic equation. Already we know this. The formula for the characteristic equation is determinant of A minus lambda is equal to 0. Or we have to take another formula for the characteristic equation. If a 2 by 2 matrix is given, lambda square minus k1 lambda plus k2 equal to 0, where k1 is sum of the diagonal elements and k2 is determinant of A. Suppose if we given the 3 by 3 matrix is lambda cube minus k1 lambda square plus k2 lambda minus k3 is equal to 0. Where k1 equal to sum of the diagonal elements, k2 equal to sum of the minor of matrix in diagonal, k3 is the determinant of A. After finding this k1, k2, k3, just we substituting the above equations. Next step, just we solve the characteristic equations. They have getting lambda 1, lambda 2, lambda 3 and so on. It is called eigenvalues. Now to find out eigenvectors. First of all, we consider the system of linear equation is A minus lambda I into x is equal to 0. Here x is called eigenvectors. This eigenvectors should be any one of the values is not equal to 0. X value should be any one of the values, minimum any one of the values not equal to 0. Now, how to solve the system of equation? I will give the some examples. X1 plus 3 x2 minus x3 equal to 0. X1 plus x2 plus x3 is equal to 0. Just we solving these two equations. X1 divided by determinant of the coefficient of x2 and x3. Next, equal to x2 divided by determinant of x1 and x3 coefficients. X3 divided by x1 and x2 coefficient. We know this determinant of 2 by 2 matrix. Just we take the cross multiplication, we will be simplify, we get the eigenvectors. Sometimes the all the system of equations we getting equal. In this case, we using this cross multiplication method, all the eigenvectors should be equal to 0. What I told already discussed, x be this eigenvectors, it should be not equal to, any one is not equal to 0. So in this case, we have to assume that two unknown value is equal to k1 and k2. After we substitute k1, k2 instead of x1 and x2 above the equal equation. After we find out x3 is equal to, from the equation we find out x3. Finally, we'll be get the form is k1, k2, 1 by 3 minus k1 minus k2. In this form, we'll be got it. Finally, we have to assume that k1 and k2 is equal to minimum number of values. Okay. Next. Now, some property we now the discuss about the properties of eigenvalues and eigenvectors. Depending on these properties only, we are asking these questions. Now, the first one, the property number one, the sum of the eigenvalues of A is also equal to the sum of the principal diagonal elements. Suppose you want this sum of the eigenvalues, just once we given the matrices, what is the eigenvalues of the sum of the eigenvalues of the given matrix? அப்படின்னு கேட்டானா don't need to find eigenvalues. Directly we identify sum of the eigenvalues. The sum of the eigenvalues is also equal to what? Sum of the principal diagonal elements. That's all. Now another one. The product of eigenvalues of the matrix is also equal to what? Determinant of A. Next, if the lambda 1, lambda 2, etc. lambda n or be the eigenvalues of matrix A, then the eigenvalues of K are K be the scalars. Scalar means some constant multiplication. Just will be multiply with the given eigenvalues for the corresponding constant. Suppose lambda 1, lambda 2, etc. lambda n be the eigenvalues of A means the eigenvalues of Ka is K lambda 1, K lambda 2, K lambda n, etc. Suppose the eigenvalues of A power P or lambda 1 power P, lambda 2 power P, etc. lambda n power P. The eigenvalues of A inverse or lambda 1 inverse, lambda 2 inverse, and lambda 3 inverse, and so on, lambda n inverse. Next property, the square matrix of A and its transpose A transpose have the same eigenvalues. Suppose if the given matrices be the A, we find out the eigenvalues of given matrix A and A transpose both are what? Similar. This is for the property number 4. Now, for example, we consider A with a given matrix. This is for the matrices 1, 1, 3, 1, 5, 1, 3, 1, 1. Okay. Suppose if you are asking the sum of the eigenvalues, so sum of the eigenvalues equal to what? Sum of the diagonal elements. So the sum of the diagonal elements. So what are the diagonal elements here? 1, 5, 1. Just we have to take additions. 1 plus 5 plus 1, so 7. So sum of the eigenvalues is equal to 7. Suppose you are asking the product of eigenvalues, just we take the determinant of given matrix. So the determinant of 1, 1, 3, 1, 5, 1, 3, 1, 1. So simply we will be getting the value is 36. So the product of eigenvalue is 36. Sum of the eigenvalue is 7. Okay. Uh, by using this above topics, we get the simple questions. Are you visible for this? Anyone? Are you visible?
Yes, sir.
Okay. Uh, listen, in our gate or anywhere we are to writing anywhere we are going to write some comprehensive test or aptitude test or government sector examination, we have to ask for in these types of questions. Okay. Now here two eigenvalues of the matrix is given. 2, 2, 1, 1, 3, 1, 1, 2, 2 are equal to 1 each. Find the eigenvalues of A inverse. Always using just some of the properties. Only we have to using the properties of eigenvalues and eigenvectors. Here, given the matrix of order is 3, the possible eigenvalues is what? 3 eigenvalues. Here, the given 2 eigenvalues of matrix are 1, 1. 2 eigenvalue is given, but we find out one more eigenvalue. That means the third eigenvalues. Now, it will be considered third eigenvalue is lambda. Third eigenvalue is lambda. We know this the properties. Sum of the eigenvalue is equal to determinant of sum of the principal elements. That means the leading elements. What is the sum of the diagonal elements? 2 plus 3 plus 2. So 7. If I give, we know these two eigenvalues. Sum of the eigenvalues 1 plus 1 plus third eigenvalues we have to finding values, unknown values, lambda. So 2 plus lambda is equal to 7. So what is the lambda? Lambda is equal to 5. So simply we'll be got it third eigenvalues. So now the eigenvalues of A is equal to 1, 1, 5. What is our question? Find the eigenvalues of A inverse. Inverse means by the next one more properties. Inverse means just we find out inverse of the eigenvalues of A. So 1 inverse 1, 1 inverse 1, 5 inverse 1 by 5. Now we got it. The eigenvalues of A inverse is equal to 1, 1, 1, 5, 1 by 5. Now the product of two eigenvalues of the matrix. The product of two eigenvalues of the matrix is 16. Find the third eigenvalues. Two eigenvalues of product means lambda 1, lambda 2 is given 16. We find out the eigenvalues of third eigenvalues. The product of eigenvalue is equal to determinant of A. We know this is the properties. Now by the property, lambda 1 into lambda 2 into lambda 3 is equal to determinant of A. We take the given matrices determinant 32. So lambda 1, lambda 2 is, we know this 16. Just we substitute, lambda 3 is equal to 32 divided by 16. So what will we get? 2. So the third eigenvalue is 2. Next. If A is a orthogonal matrix, so that A inverse is also orthogonal. That means just we take B equal to A inverse. B is we consider A inverse. Just we take the transpose. B transpose is equal to A inverse whole transpose. Now A transpose is equal to B. So B equal to A inverse is orthogonal. In these types of questions, only asking the properties. That's all. Now, very important. Find the constants A and B such that the matrices A 4, 1, B has 3 and minus 2 has its eigen values. Okay, simply we find out the value of A and B. Its eigen value is given. We know this. Sum of the diagonal values is also equal to sum of the eigen values, one of the property. So sum of the diagonal means A plus B equal to 3 plus minus 2. This is also equal to 1. We consider this is equation number 1. Next, we know this the product of eigenvalue is equal to determinant of A. So the determinant of A is equal to AB minus 4. A determinant of A is equal to AB minus 4. So what is the product of eigenvalues? 3 into minus 2, minus 6. So AB equal to minus 2. Just we solving these first two equations, will be get A and B. So A is equal to 2, B is equal to minus 1. Now, it is already will be seen if the system of equations, how many equations given? 3 equations. Has non-trivial, find the value of lambda. Non-trivial means if just we find out the determinant. So first of all, we take the coefficients of the given system of equations. So what are the coefficients of system of equations? 1, 2, 1, 5, 1, 1, 1, 5 lambda is equal to 0. Just we will be take the determinant lambda is equal to 3. Once we are asking non-trivial solutions, Just we take the determinant of the given matrices will be get lambda is equal to 3. Now sum and product already will be seen, right? Next, one of the eigenvalues of given matrices is minus 9. Find the other two eigenvalues. So one of the eigenvalues only given. We find out other eigenvalues. If the given matrices is 3 by 3 matrix, once we given 3 by 3 matrix, uh, order is 3, no? So the possible eigenvalue is also 3 eigenvalues. So in this case, by the we using the properties, we take other two unknown eigenvalues, we consider a and b. Sum of the eigenvalues equal to sum of the diagonal elements. So a plus b plus minus 9 equal to sum of the diagonal elements. 7 minus 8 minus 8. One more. Product of eigenvalues is equal to determinant of a. For determinant of a equal to product of eigenvalues, no? So we will be simplify. We get ab equal to minus 49. Now we simplify these both the equations. A plus b equal to 0 and a plus b equal to minus 49, and then will be get the possible answer is a is equal to minus 7, b is equal to 7. This is for the required answers, other eigenvalues. Next, prove that the eigenvalues of minus 3a inverse are the same as those of a is given. Already I'll be mentioned how to find out the eigenvalues. First of all, we take a be the given square matrix. After we know this the characteristic equation. Determinant of a minus lambda equal to 0, or lambda square minus k1 lambda plus k2 equal to 0. K1 is what? Sum of the diagonal elements. K2 is determinant of a. Just we will be find out the characteristic equations. After we solving this the characteristic equations, we will be get the eigenvalues is minus 1 and 3. Now you want this eigenvalues of minus 3 a inverse, no? First we want this find out a inverse of eigenvalues. So the eigenvalues of a inverse is we take inverse, that means reciprocal. After we multiply by minus 3. So the eigenvalues of 3a inverse are 3 minus 1. Next, if the sum of two eigenvalues and trace of 3 by 3 matrix are A are equal. In our question, sum of two eigenvalues and trace of 3 by 3 matrix. So if in our questions is simply will be mentioned the given matrices of order is 3. So they have how many possible eigenvalues? 3 possible eigenvalues. But here the first condition is sum of two eigenvalues is equal to trace of 3 by 3. Trace means what? Sum of the diagonal element. So lambda 1 plus lambda 2 equal to lambda 1 plus lambda 2 plus lambda 3. So simply we identify lambda 3 equal to 0 because the lambda 1 lambda 2 is cancelled. And our question is we are asking the value of determinant of A. The determinant by the property determinant of A is equal to what? Product of eigenvalues. Lambda 1, lambda 2 is unknown, but lambda 3 is 0. 0 into anything? 0. So the product of eigenvalue is also is equal to determinant of A. No? So the required solutions, the determinant of A is equal to 0. Two of the eigenvalues of A is mentioned minus 1, minus 1. Here mentioned by two eigenvalues, but the given matrix is 3 by 3 order. So they have possible eigenvalues is three possible values. First of all, we find the third eigenvalue. We know this the properties of eigenvalues. Sum of the eigenvalues equal to sum of the diagonal elements. By using this property, we find out the third eigenvalue. So lambda 1 plus lambda 2 plus lambda 3 is equal to 1 plus 1 plus 1. Lambda 1 lambda 2 minus 1 minus 1. So simply we will be identify lambda 3 is equal to 5. Now the eigenvalues of A is 1, 1, 5. So what is the A inverse? A inverse means just we take the reciprocal. Okay. Next. Now, find the sum of the square of the eigenvalues. Sum of the square of the eigenvalues. Suppose once we given the matrices is lower triangular matrix or upper triangular matrix. Lower triangular or upper triangular matrix. The eigenvalues is are also the diagonal elements. Now below the diagonal elements, all the elements are 0. All the elements are 0. So in this case, the eigenvalues of the matrix is also equal to the diagonal elements 1, 4, 6. These are all the eigenvalues. Now our question is sum of square of eigenvalues. First of all, we are squaring the given eigenvalues 1 square, 4 square plus 6 square. Now we are taking additions. So 1 square plus 4 square plus 6 square is equal to what? 53. So the required answer is 53. Okay. In this way, we have to find out, we identify, and also we identify the solutions of these problems. Okay. This is for our topics of linear algebra. Now I will be discuss about the another topics. If you have any doubt for linear algebra, anyone? Matrices, rank of the matrix, consistence and inconsistence. If you have any doubt, any doubt? Now I am going to discuss about differential equations. Listen, differential equations. First we consider the given differential equation is a naught d square y by dx square plus a1 dy by dx plus a2 y equal to f of x. It is also called the second order differential equations with constant coefficients because the derivative coefficients involving a0, a1, a2 and so on. Okay. We consider a0, a1, a2 be are the constants. This is our what? Constants. So it is differential equations with constants coefficients. Here asking one of the questions. Sometimes we identify the order and the degree of the differential equations. For example, we consider the second one. D cube y by dx cube whole square plus a1 d square y by dx square whole power 4 plus dy by dx plus 4y equal to x square. From the equation 2, what is the higher order? Here higher order equation is, higher order derivative is 3. So the order of equation is 3. The corresponding power is 2, no? So the degree of equation is 2. So here order is 3, degree is 2. Okay. Once we have to asking the question is order and the degree of the differential equation. Order means the higher derivative is called what? Order. Corresponding power is called what? Degree. Okay. Now it is called the second. In from the equation 1, it is a second order equations. This corresponding power is what? 1, no? So the degree is 1. order is 2, degree is 1. From equation 2, order is 3, degree is 2. Now, how to solve the differential equations? We know this. The notations of d by dx is capital D. D square by dx square is we consider capital D square. Now we know this capital D means a differentiation. This inverse is called what? Differentiation inverse integration. So 1 by d is integration with respect to x. 1 by d square means integrating with respect to x in twice. First, we find out auxiliary equations. Auxiliary equations means instead of d, just we replace by m. So the given differential equations we replace the d by m. So a naught m square plus a1 m plus a2 equal to 0. Solve these equations. Solve this auxiliary equations. We get the possible roots m1, m2, etc. Some values. It is called roots of the equations. Depending on these roots, next we identify the complementary functions. They have three possibilities. One is if roots are real and equal, another one is roots real and different, roots are real and imaginary. They have three possible roots is exist. If the roots are real and equal, the complementary function is equal to a plus bx into e power mx. If the roots are real and different, the complementary function equal to a e power m1x plus b into e power m2x. The roots are real and imaginary. Complementary function is e power alpha x, a cos beta x plus b sin beta x. Now we find out the particular integral. Suppose if the given differential equations involving the right side is equal to some other values, some values. But if, for example, exponential, trigonometry, and algebraic function, something. If once we involving exponential functions, we substitute d is equal to a. Suppose the right side is only involving the constant term, we substitute d is equal to 0. If we'll be involving a hyperbolic trigonometry function, for example, sine h theta, cos h theta, we converted to in terms of exponential after we using the similar procedure. For example, sine h theta means e power theta minus e power minus theta divided by 2. Cos h theta is equal to e power theta plus e power minus theta divided by 2. Next, if you given trigonometry function sine or cos, d square equal to minus of a square. Now, if once given the trigonometry functions, we know this substitution is what? D square equal to minus of a square. In conjugation, what is the how to we will substitute the value of d? In this case, we use the conjugate. Conjugate means denominator just interchange the sign and will multiply and divide it. So automatically d minus a divided by a plus b into a minus b is what? A square minus b square. So simply we'll be get it d square minus a square. Okay. Next, we find out the third type, algebraic function. Algebraic means all the x, x square, x cube, x power 4 and so on. In this case, first step, denominator converting to 1 plus x or 1 minus x. This is the second step, it is converting to numerator 1 plus x whole inverse, 1 minus x whole inverse edges. We know this is the binomial expansions. 1 plus x whole inverse equal to what? 1 minus x plus x square minus x cube plus and so on. 1 minus x whole inverse equal to 1 plus x square plus x cube plus etc. After expansions, just we will multiplying all the terms and we simplify, we will get the solutions. Next, fourth type of the given differential equation is exponential multiply with any other function. For example, e power ax into f of x. In this case, e power ax into x square or e power ax into cos ax. First of all, we substitute instead of exponential multiplication cases. In this case, first replace d is equal to d plus a. After, if we are multiplying trigonometry functions, we use this type 2. If multiplying algebraic functions, we use the type 3. Next, note. Suppose the particular integral of the form is 1 by pi of d into RHS. Suppose after substitution of d, denominator suppose we will get 0. Anything by 0 is equal to what? Infinite. So once we are getting infinity form, Numerator multiplying x, denominator we differentiate with respect to d. 1 second will be getting zero form, anything by zero form, that means infinite form. Again we'll multiply by x. Again we differentiate with respect to d in denominators. Next, Euler's-Cauchy's equation. Euler's-Cauchy's equations means if the differential equations with constants coefficients means only involving the constants. Suppose if it will be involving the coefficients of derivative is a variable, x, x square and so on, it is called what? Variable coefficients or Euler's-Cauchy's equations. In this case, first of all, we are converting to differential equations with the constant coefficients. The conversion of constant coefficient is we have to apply x is equal to e power z and z is equal to log x. X dy by dx equal to theta y, x square d square y by d square equal to theta into theta minus 1 into y. We, we substituting these relations in these above equations, it will be converted to differential equations with the constant coefficients. Now again we use the same as the differential equations with the constant coefficients concept. That's all. Next, boundary value problems. Boundary value problem they have classified three different ways. One is elliptic equations, one is parabolic equation, another one is hyperbolic equations. So for example, the first one, wave equations. Wave equations means the general wave equation is dou square y by dou t square equal to a square into dou square y by dou x square. Here a square is called tension by mass, T by m. By using separable variable method, suppose we have to solving this wave equation, they have three possible solutions. One of the solution is y of x comma t is equal to a e power lambda x plus b e power minus lambda x, c e power lambda a t plus d into e power minus lambda a t. Another one we getting in terms of trigonometric solutions. Y of x comma t is equal to a cos lambda x plus b sin lambda x into c cos lambda a t plus d sin lambda a t. Another one, algebraic solutions. Y of x comma t is equal to ax plus b into ct plus d. These are the possible solutions of what? Wave equation. Another one, examples for elliptic is heat equations. Dou u by dou t equal to alpha square dou square u by dou x square. Here we are to solving the have three possible solutions. U of x comma t is equal to a e power lambda x plus b into e power minus lambda x, e power lambda square alpha square t. U of x comma t equal to another solutions, a cos lambda x plus b sin lambda x e power minus lambda square alpha square t. Next one, u of x comma t is equal to ax plus b into c. This is a possible solutions of what? Heat. Similarly, two-dimensional heat equations are Laplace equations. Generally, the equations of Laplace dou square u by dou x square plus dou square u by dou y square equal to 0. By using the separable variable method, how to solve the Laplace equation, the edges to the possible solutions are u of x comma y equal to a e power lambda x plus b e power minus lambda x into c cos lambda y plus d sin lambda y. Another one, u of x comma y equal to a cos lambda x plus b sin lambda x, c e power lambda y plus d into e power minus lambda y. U of x comma y is equal to ax plus b cy plus d. Next, how to classify the partial differential equation. Let us consider the partial differential equation is a dou square u by dou x square plus b dou square u by dou x dou y plus c dou square u by dou y square plus dou u by dou x plus dou u by dou y whole square equal to f of x comma y. In the same equation is also will be written as uxx, uxy, uyy, ux, uy whole square and so on. Just we consider the coefficient of uxx, uxy, uy only. Uxx coefficients we consider A, Uxy coefficients we consider B, Uyy consider C. Now we find out B square minus 4AC. Once B square minus 4AC value is less than 0, this equation is called what? Elliptic. If the B square minus 4AC is equal to 0, it is called a parabolic. If B square minus 4A is greater than 0, it is called what? Hyperbolic equations. Now just let us go through for some problems about the differential equations. Now see, suppose in our questions, solve the equation d square y by dx square equal to y. In this case, we know this is the solution. D square y by dx square, the y will be converted to left side. And d square minus 1 into y equal to 0. We find out auxiliary equations here. M square minus 1 equal to 0. So m square is equal to 1. M is equal to plus or minus 1. So if the roots are real and different, what are the possible solutions? How to write down the complementary functions? Okay. Y is equal to a e power minus x plus b into e power x. This is the solutions of the given differential equations. Next, find the particular integral of d square minus 2d plus 1 into y is equal to cos hx. So the solution is where cos hx is equal to, we know that formula, hyperbolic trigonometry functions, no? So first of all, we converted to in terms of exponential functions. So e power x plus e power minus x divided by 2. Now the question is only asking the particular integral. So only given the function is exponential, what is the substitution of particular integral? D is equal to a only. A means the coefficients of exponential functions, the constant terms. So 1 by 2, 1 by d minus 1 whole square, e power x plus e power minus x. Just we substitute instead of d, 1 and minus 1, will be get the required answer. So what will be getting? Once we getting the denominator equal to 0, numerator multiplying by x and denominator we differentiate with respect to d. Again we getting the denominator is 0. Again we'll multiply x in numerator, denominator we differentiate with respect to d. So automatically we'll be get the solution is x square e power x by 4 plus e power minus x divided by 8. Now solve that equation d square plus d plus 1 into y is equal to 0. First of all, we consider the auxiliary equations. We replace d by m. So m square plus m plus 1 is equal to 0. It is not a factorizable function. So in this case, we use the formula for quadratic equation minus b plus or minus root of b square minus 4ac divided by 2a. Here the m square coefficient is we consider 1. M coefficient is 1 and constant term c is equal to 1. Just we substitute the formula m is equal to minus 1 plus or minus root of b square is 1 and 1 minus 4 into 1 into 1 divided by 2. So minus 1 plus or minus I into root 3 divided by 2. So what is the real values here? Minus 1 by 2 and imaginary value is root 3 by 2. So the complementary function is equal to e power minus x by 2 a cos root 3 by 2 x plus b sin root 3 by 2 into x. So it is for the required solutions. In this way, we have to identify particular integral and complementary functions. In these types of questions only we are asking our gate examinations, and also any government examinations we have to writing. This is a possible questions for the differential equations. So suppose by using Euler's Cauchy's equations, this is a possible. Convert x cube d square plus 3x square d plus 5x into y equal to 2 into differential equations with the constant coefficients. Suppose if we will be given this differential equations with the variable coefficients, the first possible one is we convert differential equations with the constant coefficients. Already we know this. The substitution of Euler's equations is x equal to e power z, or z is equal to log x, and x dy by dx is equal to theta y, x square d square y by dx square equal to theta into theta minus 1 into y. We substituting these concepts in this above given equations, automatically it will be converted to differential equations with the constant coefficients. So d square y by d z square plus 2 dy by dz plus 5 into y equal to 2 e power z. We got it in this form. This is for one of the possible questions from differential equations. Otherwise, sometimes you are asking this, solve the Euler's equation. Once we are asking to solve the equations, after conversions of differential equations with constant coefficients, again we have to solve by using differential equations with the constant coefficients. So for example, x square d square y by dx square plus 4x dy by dx plus 2y equal to 0. This is a Euler's equations, no? That means the differential equations with the variable coefficients. In this case, we know this the substitution. The substitution is x equal to e power z, z is equal to log x. Therefore, the given differential equations in reduced to the differential equations with the constant coefficients. Theta square plus 3 theta plus 2 into y is equal to 0. Now we have to write down the auxiliary equations. Auxiliary equations means m square plus 3m plus 2 equal to 0. After we will identify the value of m. M is equal to minus 2 and minus 1. If the roots are real and different, no, so a e power minus 2 z plus b e power minus z. After getting these solutions, again we will be converted to in terms of x. X means we know this x is equal to e power z. E power z is equal to x, or z is equal to log x. Just we substitute here, we'll be get the solutions of y is equal to a by x square plus b by x. Okay. Now, the examples for classifications of partial differential equations. Here, y square uxx minus 2xy uxy plus x square uyy plus 2ux minus e3u equal to 0. Now, just we identify the value of a, b, c. A means the coefficient of uxx is considered a. So, here a is equal to y square, b is equal to minus 2xy plus c is equal to x square. Whatever value of a and b, just we substitute b square minus 4ac. So we identify b square minus 4ac is equal to 4x square minus square minus 4xy square. So automatically will be cancelled, it will be getting 0. If the b square minus 4ac is less than 0, it is elliptic equation. Suppose if equal to 0, parabolic. Is greater than 0, it is hyperbolic equation. So in this first example, so b square minus 4ac equal to 0, no? So it is called what? Parabolic equations. Similarly, we take the one more examples. Y square uxx plus uyy plus ux square plus uy square plus 7 equal to 0. Whatever it is given equations, only we consider the second order derivatives uxx, uxy, uyy. These coefficients we consider capital A, B, C. Here A is y square, B is 0, and C is equal to 1. Just we substitute minus 4y square. Here in the b square minus 4 is we getting in terms of some unknowns. Unknowns means some other variables. So here whatever we substituting value of y, here y square no. So any value we substitute. So negative into positive always we getting negative. So it is less than 0. So this corresponding equation is considered what? Elliptic equations. But here y is not equal to 0. Suppose if y is taking 0, 0 and anything 0. Once we getting b square minus 4ac is equal to 0, it is parabolic. If less than 0, elliptic. So this is for the differential equations. Any doubt about the differential equations? Anyone? Anyone? Now I am going to discuss about the next topic, complex variables. In a complex variable, analytic functions. If an analytic functions means if a given f of z, that means of a complex variable z, is said to be analytic at a point z naught of the z plane if it have the derivatives f dash of z naught at that point. This for the definitions of analytic functions. Suppose if a given analytic function is satisfied the Laplace equation, it is also called harmonic functions. Now the CR equations of analytic function is dou u by dou x equal to dou v by dou y and dou u by dou y equal to minus dou v by dou x. The every analytic functions is satisfy CR equation. It is also called what? The given complex function f of z is satisfy the CR equation. It is also called what? Analytic functions. So once the analytic f of z is analytic function, it should be satisfied the CR equation. This is CR equations means dou u by dou x equal to dou v by dou y and dou u by dou y equal to minus dou v by dou x. Suppose we have to show that the given function is a harmonic function. Harmonic means what? Once the given real or imaginary functions, it will be satisfy the Laplace equations. It is called what? Harmonic function. So for examples, we consider u is equal to e power x cos y. First, we find out the both the derivatives. That means a partial derivative. Dou square u by dou x square plus dou square u by dou y square. We have to getting the dou square u by dou x square means we differentiate partially with respect to x in twice. So here y term is considered constants. So cos y is we consider constant. E power x differentiation is e power x. One more times we have to differentiate x. E power x differentiation e power x. So e power x into cos y. Minus suppose we differentiate partially with respect to y, e power x is we consider constant. Cos y differentiation is what? Minus sin y. One more time so we differentiate sin y cos sin y differentiation is again cos y. So simply we'll be getting dou square u by dou x square plus dou square u by dou y square equal to 0. Once the Laplace equation is satisfied, the given function is called what? Harmonic functions. So for examples, we take one more examples. Verify the function pi of x comma y equal to e power x sin y is a harmonic or not. Now here pi is given e power x sin y. We find out first two derivatives, dou square dou u by dou x and dou u by dou y. After dou square u by dou x square, dou square u by dou y square. Just we substitute the Laplace equation. Dou square u by dou x square, dou square u by dou y square. Simply will be got it e power x sin y minus e power x sin y. So it is cancelled 0. So it is satisfied Laplace equation. So the given equation e power x sin y is called what? Harmonic function. That's all. Suppose if you are asking this, if given f of z f of z is analytic or not an analytic function. F of z we know this z cube. We find out f dash of z 3 z square. Once it is a derivatable, this function is what? Analytic. So the given function f of z is z cube, f dash of z is 3 z square. So it is a this derivative is exist at every point. Therefore, this given f of z equal to z cube is analytic functions. We take one more examples for problems. W equal to z square. Now W equal to Z square. First of all, otherwise we have to satisfy the Laplace equation. It is analytic function. The how using any way, any one way. We are using any one of the method. One is the derivative exists. It is also analytic function. Otherwise, it is satisfy the Laplace CR equation. It is also called what? Analytic functions. Now we consider W equal to Z square be the given function. We have to replace Z is equal to X plus IY because this complex variable is equal to what? Z. So Z is we consider X plus IY. Here complex function is the W. W is we consider U plus IV. Okay, U be this real function, V be this imaginary function. Now we substitute W is equal to U plus IV, Z is equal to X plus IY. And we expand. A plus B whole square formula we know this. X square plus 2ab, 2x plus iy, and then plus b square, iy whole square. So x square minus y square plus I into 2xy. So the real part is use x square plus x square minus y square. Imaginary part is v is equal to 2xy. Now we find out dou u by dou x and dou u by dou y. We differentiate partially with respect to x and y. So differentiating partially with respect to x here, 2x. We differentiate partially with respect to y means minus 2y. Similarly, dou u by dou x is equal to 2y. Dou u by dou y is equal to 2x. We comparing this dou u by dou x and dou u by dou y and dou u by dou y and dou u by dou x. So dou u by dou x equal to dou v by dou y and dou u by dou y x is equal to minus dou u by dou y. Now it is satisfied the Laplace equation. So the given W equal to f z square is analytic functions. And the next one is Cauchy's integral theorem. Cauchy's integral theorem means if f of z is analytic and its derivative f dash of z is continuous at a point on and inside a simple closed curve C, then integral over C f of z dz is equal to 0. So once we ask in the Cauchy's theorem or Cauchy's fundamental theorem, integral over C f of z dz is equal to 0. In Cauchy's integral formula means if f of z is analytic inside and on simple closed curve C, then C is encloses a simply connected the region capital R, and if A is any point in R, then f of A is equal to 1 by 2i integral over C f of z minus divided by z minus A into dz. It is considered Cauchy's integral formula. Suppose the derivatives of Cauchy's integral formula. That is, f dash of a equal to 1 by 2 pi I integral over c f of z divided by z minus a whole square dz. In this a similar way, f double dash of a is equal to 2 factorial divided by 2 pi I integral over c f of z divided by z minus a whole cube dz. In generally, it is f n of a is equal to n factorial divided by 2 pi I integral over c f of z divided by z minus a whole power n plus 1 into dz. Okay. Suppose Taylor series means f of z is analytic inside a circle C with center at A and radius is R. Then at each point z inside f of z equal to f of a plus z minus a f dash of a by 1 factorial f double dash of a by 2 factorial z minus a whole square plus etc. In a Maclaurin series, just we substitute instead of a is equal to 0. So simply it will be written as f of z equal to f of 0 plus f dash of 0 by 1 factorial z plus f double dash of 0 by 2 factorial z square plus so on. In a Lorentz series expansions, if C1 and C2 are two concentric circles with center at A and A, A and B, radius R1 and R2. If R1 greater than R2 and if f of z is analytic on C1 and C2 and in angular region R between C1 and C2, then at each point z in R. That is f of z equal to sum of n equal to 0 to infinity a n z minus a whole power n plus sum of n is equal to 1 to infinity b n divided by z minus a whole power n. That means one is the positive powers, another one is the negative powers. Here, in a residues evaluation of residues, they have the different ways. One is if the pole of order is 1, the residues of f of z at z is equal to a is limit z tends to a, z minus a, f of z. Suppose if you will be given the double pole, limit z tends to a, d by dz, z minus a whole square, f of z. In this similar way, if z is equal to a at the pole of order is m, the residues of f of z at z is equal to a will be written as 1 by m minus 1 factorial limit z tends to a d power m minus 1 by d z power m minus 1 z minus a whole power m into f of z. If asking the Cauchy's residues theorem, before finding this residues theorem, first of all we find out the residues at each pole. In a Cauchy's residues theorems, if f of z is analytic on inside a simple closed curve C except for a finite number of single points a1, a2, etc. an lying inside the given region, that means in given the region C, then integral over C f of z dz equal to 2 pi I into sum of the residues. That is the residues 1, residues 2, etc. Residues n. Of some examples from the above topic. Suppose the question is asking evaluate integral over c z minus 3 whole power 4 into dz, where c is the circle mod z minus 3 equal to 4. If here the given the circle is a closed region, no? Mod z minus 3 is equal to 4. Here f of z we consider the given integral of the functions. So f of z is equal to z minus 3 whole power 4. It is analytic inside and C. By the Cauchy's integral theorem, integral f of z dz is equal to what? 0, no? So the given integral of the form is 0. Next, suppose evaluate integral over C dz divided by z plus 4, where C is the circle, mod z is equal to 3. Now suppose if you given mod z is equal to 3, just we expand this equation. Z is, we know this, x plus iy. So modulus of x plus I is equal to 2. So root of x square plus y square is equal to 2. We cancelling the modulus. So simply will be written as x square plus y square is equal to 2 square. So it is the center of the circle is origin and radius is equal to 2. Now we have to identify the pole of the equations, pole of the given equation. You consider f of z is 1 by z plus 4. So here the pole is denominator just equating to 0. So z plus 4 equal to 0, z is minus 4. So here z is minus 4 is a singular point, or it is also called the pole. So this pole is minus 4, but the given circle is mod z is equal to 2. The center of the circle is what? 2. But here the point of z is equal to minus 4. So it is lies outside the circle. So once outside the given pole is lies outside the circle, the corresponding integral is equal to 0. So integral over c dz by z plus 4 is equal to automatically 0. That's all. Similarly, in this seventh example, just we have to see here, find the value of integral over c e power Are you listening? Now visible? Can you hear me? Can you hear me?
Sir, voice is audible, sir. Screen not visible.
Now? Now
No,
voice
sir.
is audible? No.
Yes, sir. Yes, yes. Voice is audible, sir. Screen not visible.
Okay, 1 second. Actually, um in our class only we have to allotted for 4 hours only. Okay. So I'll be forward our material also. Further, if you got any doubt, just we come and meet me. Otherwise, we will be call me. I will clear your doubt. Okay. They have many materials available to me. Okay, come and collect me. Whatever you want. Otherwise, I will be sent to your email account. Okay, because the
Okay.
time is very less.
Thank you.
Now, just I will be present my screen. Please ensure your screen is visible or not. Now visible?
Yes, sir.
Oh, okay, thank you. 1 second. Yeah, right. Well, listen. Actually, from the differential equations, the possible question is that means complex variable, they have the possible question is very less. The less means our we have to discuss only for the Cauchy's Riemann equations. That means the CR equations. First, we have to identify the what are the CR equations. Dou u by dou x is equal to dou u by dou y. Once the given analytic function, given f of z, that means complex function is to satisfy the CR equation. Its function is called what? Analytic function. Again, after from the complex functions, it is defined by different types of the theorems. One is for the Cauchy's integral theorem, Cauchy's residues theorem, and Cauchy's integral theorem, and fundamental theorems. Next, Taylor series and Laurent series. Now we have to discuss about the Cauchy's residues theorems. For examples, you will be given to the problem, evaluate integral over C 2 dz in divided by z minus 1 z plus 3, where C is the circle. It always will be given the circle is in terms of z only. Z already we know this complex variable. Z is defined by complex variable x plus iy. Suppose you want this equation of the circle, just we replace z is equal to x plus iy and we will be simplify. Will be get the equations x square plus y square is equal to r square. In this forms we will be got it. Okay. After just we have to draw the graph, otherwise we substitute the corresponding pole of equations. That means the pole we just we substitute the pole. This pole is lies inside the circle. We find out the residues after we applying the residues theorem. So otherwise directly we have to use this Cauchy's integral theorem. Anyone we have to use. Suppose if the pole is lies outside the circle, the pole is lies outside the circle, the given integral of the form is 0. Directly we have to write down the solutions of the integral is equal to what? 0. That's all. Okay. So for example, we see here in this problem, the pole is z is equal to 1, z plus 3 equal to 0, z is equal to minus 3. How to identify the pole means that given function denominator equating to 0. Just we identify the value of z. So here z is 1 and minus 3. So we just we substitute z is equal to 1 and minus 3 here. The given region. It is a less than 2 inside the circle. If greater than 2 outside the circle. Suppose z is equal to, we substituting here 1. Modulus of z minus 1 is equal to what? 1 minus 1, 0. But what is the center of the circle? 2. So z minus 1 is equal to 0. So, but here the radius is 2. So it is a less than 2. 0 means less than 2. So it is 1 is lies inside the circle. Similarly, we substitute z is equal to minus 3 here. Minus 3 minus 1 is what? Minus 4. So simply will be written as 4. So 4 is less than 2 or greater than 2. It is greater than 2. So greater than 2 means this 4 is lies outside the circle. So z is equal to minus 3 is outside the circle. Z is equal to 1 is lies inside the circle. Once inside the circle, we find out the residues. Suppose if outside the circle, the corresponding values is what? 0. So the totally only we find out the residues of f of z at z is equal to 1 only. After getting the residues, we substitute the Cauchy's residues theorem or Cauchy's residues integral formula, will be get the solutions. Okay. In these types of questions only we ask from complex variables. Okay. Suppose from the Taylor series, obtain the expansions of log of 1 plus z, where mod z is less than 1. Suppose you are asking the Taylor series expansions. Taylor series expansions. If whatever it is, if the given question is the point is not mentioned, point at the point is not given, always will be take the value is 0. So we use only for the Maclaurin series. Maclaurin series means what? F of Maclaurin series. Already will be discussed the Maclaurin series. F of z is equal to f of 0 plus f dash of 0 by 1 factorial z plus f double dash of 0 by 2 factorial into z square and so on. Okay. Now, the given function is we consider log of 1 plus z. So f of z is equal to log of 1 plus z. So we similar in this similar way we find out f of 0. So here f of 0 is equal to log of 1 plus 0. Log 1 is 0. f dash of z. We find out the first derivatives. Differentiate with respect to z. Log of 1 plus z differentiation is 1 by z plus 1. Now we substitute f dash of 0. So 1 by 1, 1. F double dash of z means, again we differentiate, minus 1 by z plus 1 whole square. So f double dash of 0 is equal to minus 1. Similarly, we find out the derivatives. After we substituting this Taylor series expansions formula, f of 0 plus f dash of 0 by 1 factorial plus f double dash of 0 by 2 factorial and so on. So simply will be got it z minus z square by 2 plus z cube by 3 minus z power 4 plus etc. Okay, that's all. Suppose we are asking the Taylor series expansions, just we find out all the derivatives, and if once we given the point, we substitute the values. Otherwise, always we take the point of value is equal to 0. We use the Maclaurin series. Okay, that's all. So in these types of questions only we have asked from complex variables. Now I will be discuss about the next topic for the vector calculus. That means a calculus. In a vector calculus, some values. If scalar point functions. Once we are scalar points function means this function is involving only for a magnitude. It is called what? Scalar point functions. So for examples, pi is considered x square plus y square plus z square. It is called what? Scalar function. If the function is involving scalar with directions, just once the given function is will be involving scalar with directions, it is called what? Vector function. Now the vector operation is del equal to dou by dou x into I plus dou by dou y into j plus dou by dou z into k vector. This notation is called what? This operations is also called del. Del means vector differentiable operators. Now in a vector functions, a gradient scalar function is defined by del phi. Del phi means del already we know this. Dou by dou x I, dou by dou y j, dou by dou z k. Here will be multiply with phi scalar function. So del phi is defined by dou phi by dou x I, dou phi by dou y j, dou phi by dou z k vectors. Similarly, by using these gradient vectors, gradient functions, we have to find out some data. One is unit normal. Unit normal vectors means n vector is equal to del phi divided by modulus of del phi. Now again we have to differentiate derivatives, directional derivatives. In a directional derivatives means, let us consider phi be the scalar functions and del phi be the gradient functions and a be this given directions. Then the directional derivative is defined by del phi dot a vector divided by modulus of a vectors. Next, the divergence vectors. Divergence vectors means vectors is equal to, we take the dot product. If f be this vector function, then divergence vector is defined by del dot f vector. Del dot f vector is taking dot product, we know this. If the same directions, we will be get 1. Suppose for example, I dot I is equal to 1. Suppose we taking I dot j, what will be get? 0. So now del dot f vector will be defined by dou f1 by dou x plus dou f2 by dou y plus dou f3 by dou z. If a curl vector means del cross f vector, we taking the cross product for the given vector functions. So I determinant of ijk dou by dou x dou by dou y dou by dou z f1 f2 f3. Just we taking the determinant of the given vector functions. Simply we have to getting the solutions of curl vectors. Next, here very important, by using this divergence and curl vectors, we have to identify solenoidal and irrotational vectors. Once divergence vector is equal to 0, the given vector function is called a solenoidal vectors. If a curl vector equal to 0, given vector function is called what? Irrotational vectors. Now some properties, identifications of the vector function. Divergence of gradient phi is also del square phi. It is defined by dou square phi by dou x square, dou square phi by dou y square, dou square by dou square. Suppose anywhere we have to asking divergence of curl vector equal to 0. Curl of gradient pi is also equal to 0. In a del product and linear product and del of pi, it is also we have to define by these functions. Next, integral. By using this vector integral, they have three different ways. Suppose if you want the line integral, integral over c f vector dot dr vectors. It is called what? If a given vector function is f, then the line integral is defined by integral over c f vector dot d r bar. Surface means surface. Surface integral means the surface integral of f over the surface is denoted as double integral over s f vector dot ds bar. By using this volume means volume integral. Next we have to define by volume integral. Volume integral means triple integral over dv. dv is defined by dx, dy, dz. This is for the three-dimensional integral. Now just we have to comparing this line and surface integral. They have using the different way of integral theorem. One is Green's theorem. Green's theorem we have to compare with what? Line and surface integral. And Stokes theorem is also compare with line and surface. What is the difference between this Green's and surface means? In a Green's theorem only will be given xy plane, but in a Stokes theorem we have to given xy plane or yz plane or z two-dimensional with any plane. Or suppose if you given the three-dimensional region, one of the region is should be opened. One of the region is should be opened. So for example, if a Green's theorem means if C is a simple closed curve enclosing a region R in the xy plane and P and Q are the first order partial derivatives are continuous in R, then integral over p dx plus q dy is defined by double integral over R dou q by dou x minus dou p by dou y dx dy. Next, cost divergence theorem. Cost divergence theorem is comparing with surface and volume integral. If S is a closed surface enclosing a region of the space with volume V, and if f is a vector functions with continuous first order partial derivatives in V, then Gauss divergence theorem is defined by double integral over S f vector dot n bar ds equal to triple integral over V divergence V into dV. Stokes theorem is also we have to comparing with the line and surface integral. If S is an open two sides surface bounded by the simple closed curve C and F is the vector point functions with continuous first order partial derivatives on S, then integral over C F vector dot dr bar equal to double integral over S curl F vector dot n bar ds. Okay. Some examples we have to noted here. If will be considered phi be the any functions, phi be the functions, or here will be mentioned by the del phi. That means the gradient phi is given. We have to find out phi. If will be del phi is given, what is the del phi here? 2xy is a cube I plus x square z cube j 3x square y z square k. Find the value of phi. Del phi we know this, dou phi by dou xi, dou phi by dou ij, dou phi by dou z k. So the direction coefficients we consider dou phi by dou x, dou phi by dou y, dou phi by dou z. Once we know this dou phi by dou x is equal to 2xy z square. What is the derivative is inverse integration. So we have to integrate, partially integrate with respect to x, we get the value of phi. We will be integrating with respect to x, we consider y and z be the constants. Okay, so we will be get the value of pi is equal to x square y z cube. Suppose you want this unit normal surfaces. Here we will find the unit normal vector to the surfaces is given x square plus xy plus z cube equal to 4. at the point 1 minus 1 2. Now the given surfaces is we consider phi x square plus xy plus z square minus 4. First of all, we find out the gradient vectors. Del phi is equal to dou phi by dou x plus dou phi by dou y j plus dou phi by dou z. Just we find out the order derivatives. After we substitute the given points. Instead of x, y, z, we substitute the given values 1 minus 1 2. 1 minus 1 2 we substituting del phi at the point 1 minus 1 2 is equal to I plus j plus 4k. We take the magnitude. Modulus of del phi is equal to square root of 1 square plus 1 square plus 16. So we getting root 8. We know already we will be define the unit normal vector. N vector is equal to del phi divided by modulus of del phi. Just we substitute this formula, we will be get the unit normal vectors. Suppose you asking the directions. Suppose we are asking the directional derivatives. Find the directional derivatives of phi is equal to 4xz square plus x square yz at the point is mentioned 1 minus 2 1. In this directions also will be given 2i plus 3j plus 4k. So here simply we know this the directional derivative is equal to what? Del phi dot a vector divided by modulus of a vector. Phi is given. Phi be this given scalar function. First we find out the gradient vectors. Del phi we have to find out. After finding the gradient vectors, we substitute the point also. The given point instead of x, y, z 1 minus 2, 1. After a is given 2i plus 3j plus 4k. So 2i plus 3j plus 4k. After we take a modulus. Modulus means modulus of a vectors. So we simplify, we'll be get the solutions. They require directional derivatives. Uh, Sometimes there's a in this vector functions from the vector function we have to show that it is a irrotational and solenoidal. Suppose if a given vector is a solenoidal means what will be find if you finding divergence vectors. Once the divergent vector is equal to 0, this function is given vector function is called what? Solenoidal. Similarly, if given vector function is satisfied the curl vector is equal to 0, it is called what? Irrotational vectors. Now, for examples, find the lambda if the given vector is a solenoidal. So if in our questions will be mentioned by solenoidal, we have to find out one unknown values lambda. Solenoidal means what? Divergence vector. Divergence means we find out the dot product of the given vector functions. So dou by dou x dou f1 by dou x plus dou f1 f2 by dou y plus dou f3 by dou z equal to 0. Just we have to find out all the derivatives, first order derivatives and equating to 0. So lambda is equal to minus 2. Similarly, uh, once we given the vector function is irrotational and we find out some other unknown values, we have to find out the curl vector. After we equating to 0, simply will be got it the value of unknown values. Okay, in these types of question is also will be have to asking from our examinations.